Okay, I already worked out our last example. We'll talk through it and then we'll do a summary of what we've talked about in this section. Basically, I want to discuss this line that's graphed below. But the line, well, the y-intercept and the x-intercept are difficult to find. Y-intercept is somewhere between 0 and 1. It looks like it's about 3/4 maybe. The x-intercept is a little bit left of -1, but I found 2 points that were exactly integer values. This one and this one. So this point is 4, 3, which is right here, and then this point here is -3, -1. So from those 2 points I computed the slope, which I got -4 over -7, which is equal to 4 over 7. So the slope is 4/7. Then I wrote the equation in point slope form using this point here. I got y minus y1, y minus 3, is 4/7, the slope, m, times x minus x1, which is 4. I get y minus 3 is 4/7 x, distributing here, minus 16 over 7, because 4 over 7 times 4 over 1 is 16 over 7. And we retain the negative sign. And then finally I added 3 to both sides, but I made a note over here. I had to add 3 to the right. On the left-hand side, those cancel out. And then when I added 3 over here, 3 is equal to 21 over 7. I needed a common denominator. So -16 over 7 plus 21 over 7 gives us 5 over 7. So just as a sanity check here, the y-intercept here is 5/7. That's almost 1. So that's actually what the height is right there. That's 5 over 7. Okay, that's our last example in this section. Now let's summarize what we learned. First, we defined the slope. The slope of the line passing through these 2 points is y2 minus y1 over x2 minus x1. We sometimes call this rise over run. How much do you have to rise for each time you have to run a certain distance? The standard equation. This I didn't really talk about too much. It's my least favorite form for the equation of a line, but it is simply a times x plus b times y equals c. So, and you actually could put the c on the left-hand side, do what's necessary to get a 0 on the right, but this is typically the way we write the standard equation. So the one we're going to use most commonly probably is slope-intercept. So the slope-intercept is y equals mx plus b, where m is the slope and b is the y-intercept. We're going to use this one, point slope equation, actually very, very frequently, but we'll finally, after we get the equation in point slope form, you'll almost always be asked to write it in slope-intercept form. Simplify it in a sense. The point slope equation is y minus y1 equals m times x minus x1, where m is, as always, the slope, and this is just a given ordered pair, or a given point, x1, x2. I'm sorry, x1, y1. How about a horizontal line? That's a special one, where y equals, I'll say a. I think last time I said y equals b, but really this can be absolutely any number. So where every point in the line has the form what? X is always 0, and then this can be absolutely any number. The slope of this line is 0. It's a horizontal line. The slope is 0. So this tells us that 0, a is the y-intercept, but all of the points have a height of a on the graph. Okay, last one, vertical line. Well, the vertical lines have the form x equal something. I'll use a again. Maybe I should have used b up here, but it doesn't matter. X equals a number, where every point on the line has the form, let's see, y is a 0, so we get a comma 0. The slope of the line in this case is undefined. And that's the end of our section on graphs and lines.